don't want to waste your neuronal energy to adapt to these. Well, part of the reason is that many a times people using patients do care, because many times it presents as skin infection. People really care about this thing. This picture over there that is based upon people's awareness, based upon presentation, it becomes very obvious, and cosmetics, beauty, all these things add on top of that. So if you do have a fungal infection, you really want to get it treated. So it's something very obvious. Most of the time, the presentation is on the skin. Anyway, let me begin with the pathogenesis of fungal diseases in this morning's lecture, and I'll begin with superficial mycosis at 11. These are some of the copyrighted figures from Dennis Kunkel's microscopy, so you can see typical. What I would want you to do is that you may want to go back and review one of the chapters in Journal Microbiology. And we spent one whole lecture, difference between yeast and mold, the basic anatomy of fungi, and all those important things that, and I think one of those tables you will notice is difference between bacteria and fungi. That's also very important for you to know. So you'll see over here the typical structure of fungi. You'll see mycelium, you see budding. You can see budding over here, this angular budding. A typical yeast-like presentation. As far as pathogenesis is concerned, pathogenesis is something that we really have to keep in mind before we can diagnose it or come up with any treatment module. Okay, objectives, of course, difference between fungi and bacteria, that's already there in the previous lecture. I will not go in detail. I want you to know the pathogenesis of fungal disease. I'm going to talk about primary fungal pathogens, and I'm also going to talk about some of the opportunistic fungi. And again, remember, we did talk about opportunism, and there are opportunistic bacteria, opportunistic viral infection, and opportunistic fungi as well. And finally, we'll talk about some of the fungi that do cause human diseases, because, of course, fungi is there in industry. You know, you got a lot of food products because of fungi, yeast, and so on and so forth. But we would not go in those details. We just limit ourselves to fungi causing human disease. Okay, now the question is that why is it there is dramatic increases in incidence and severity? There are a lot of reasons for that. One of the reasons is there's so much advances in surgery. So this means that we can actually go and explore the deeper parts of our body. Remember, these fungi may be present on your skin or mucous membrane, and normally they would not be able to penetrate and go into the deeper tissues of our body, but we help them by advancing in surgery. So once you do surgery, you open up an organ and a body, there always are chances that you may add on to fungi into that microenvironment. So these are, and then secondly, we have all those endoscopes, all those kind of gadgets that go into our cavities. That again is something that you can enter into those cavities which primarily were sterile. So that actually will also tell you why is it that the increase in incidence and severity. What about cancer treatment? Why do we have increased fungal infection in cancer treatment? Immunosuppression. Remember, these fungi are there. Actually, our immune systems are tested by fungi. Remember, in AIDS we talked about some of like pneumocystis, for example, carinine, and some other fungal infections that we normally take care of because our immune systems are patent. If you do have any compromise in the immune system, so the very first thing that's going to happen to you is infection with fungi. That immediately, if you have infection of fungi, many a time it actually shows that there is a chronic disease or there is some disease that's coming and hitting your immune system. And AIDS remain on top of that. Diabetes also is there because many a time these people will have chronic resistant fungal infections. Critical care accompanied by increases in the use of broad-spectrum antimicrobials. Why should we have fungal infection if you use broad-spectrum antimicrobial drugs? Yeah.
You shall off the normal bacterial flora that's there in the opportunistic.
Yeah, correct. The thing is that if you remove normal flora, so the replacement of that normal flora is many a time with fungi, because those normal flora actually give a barrier. So these are like barriers for any other type of microorganism. So if there's a shift of your normal flora, and if there's a shift of the number of microorganisms that are present, there always are chances that you may give these opportunistic fungi to go and sit on those places. An HIV epidemic, obviously because your immune system is suppressed, so many a time you remember we talked about this oroplakia and fungal infections that they normally present with. And the classical case of those patients who were resistant to treatment, and then remember about this pharmacist technician that she noticed that there was a refill of one of the drugs that was rare. You remember the name of that drug? What was the name of that drug that she noticed? Pentamidine. Pentamidine. Good. All right, let's move on. Just a repeat slide from the same lecture, the journal lecture. I just want you to know and remember that many questions obviously will come where you would be asked to differentiate between a bacteria and a fungi. And you can see over here they do have a cell wall, they have a cell membrane, and then they have organelles. So organelles are there including a nucleus, they have mitochondria, we have endoplasmic reticulum, and they have Golgi apparatus. So they basically are prokaryotic or eukaryotic. How many of you think that they are prokaryotic? How many of you think they are eukaryotic? They are eukaryotic. And that's the challenge that we have in devising drugs, because if you go after these drugs, you're going to have a lot of tissue damage because your own cells are eukaryotic, but obviously there are some differences, right? Okay, I don't want you to really go in detail, but just a repeat slide from one of the important aspects of immunodeficiencies. If you go back and find out in the deficiency of especially the natural immunity, all those diseases where you have immunodeficiency in natural immunity or innate immunity, you will be prone to fungal infection. Like if you have a problem with your neutrophils. If your neutrophils are unable to phagocytose, if your neutrophils are unable to generate an oxidative burst. So can you think of any disease that's very common in which there is not a good generation of reactive oxygen intermediates? There is a disease entity where the patients are unable to generate reactive oxygen species. Yeah. Legionnaires. No. Legionnaires, it has to be a immunodeficiency where your cells are able to phagocytose and not kill the microorganism because you are unable to generate reactive oxygen species. Chronic granulomatous disease. If you remember, we talked about CGD, chronic granulomatous disease. And there are many other diseases you'll find in the chapter. And remember, different fungi, they basically live in extra. Another important thing you have to remember when we talked about all those microorganisms that they sit in extracellular spaces. There's always a difference between, and many a time these fungi are there that they are in extracellular spaces, right? And if you remember pros and cons of those microorganisms that are there within the cell like viruses, what are the challenges that we have? We're going to design drugs to go and kill them, and what are the challenges that we may have for all those microorganisms which are there in extracellular space. But normally our immunity is good enough to take care of most of the fungi. A normal person should not have any fungal infection. The commonest fungal infection that an ordinary person gets is very common. Yeah, Anchor, you said it's very common. Which one is common? Common fungal infection. Very good. Athlete's foot. Very common. You see a lot of drugs over there. Doesn't really mean that you have AIDS or you have immunodeficiency, but again, this is very common. And actually, many a time people think it's because of the anatomy of our finger web. Sometimes people have, especially toes and fingers that are very close, and there is no aeration there. So this is of anatomy. And then again, if you are wearing socks and shoes and exercise, all these are environmental factors that may add your susceptibility to the fungal infections. Otherwise, you should be pretty normal. But many times people do represent having a chronic, very, very malignant and difficult to treat fungal infection. Even fungal infections are difficult to treat in other forms as well. For example, if you have fungal vaginitis, that's also very difficult to treat. So fungal infection per se, because of the limitation of drugs and because of the eukaryotic types that we may have. But all this slide tells you that unless you have an immunodeficiency, you pretty much are stable to take care of fungal infection. Your immunity should be good enough to take care of any fungal infection. Okay. There are some of the terms that we normally use. Remember, mycology is a study of fungal diseases. So fungi are also myces, or you can call them fungal infection like mycosis. There's another word we'll use commonly, mycosis. So many reasons, for example, I'll say superficial mycosis or deep mycosis, so I'm talking about fungal infections. Most of the time, these fungal infections are endemic. This means that they are already there in the environment. The commonest mode of entry of these fungi into our system is by inhalation. So you may inhale the spores so they can go and cause respiratory problems. Many a time, as it happened in AIDS patients, that these fungi were inhaled, and many a time the presentation is respiratory problems other than the skin. And we already talked about opportunistic infection because they may even go into your system. Many a times, if you have a good patent immune system, the best they would do is to cause a little bit of mild disease, right? And it's going to go away over time, unless and until you have a predisposing factor, or you have a compromised immunity, or you happen to be a severely immunodeficient. That actually is a major point that we have to keep in mind for those patients who are unable to take care of even fungi. Immediately we'll think of all those possibilities: cancer treatment, use of steroids, right? And then again diabetes, chronic infections, and AIDS. So these are the common things you immediately think in your differential diagnosis when you come across any of these fungal infections. Okay, innate and adaptive immunity both play a role, but most of the time the principal response is via innate immunity, because you don't really have to adapt to them. So the cells of immune system, especially innate immune system like neutrophil and macrophages, should be able to take care of that unless and until you have severe neutropenia. If you have remember there's another thing, many antibiotics and many drugs may have neutropenia as a side effect. Right? For example, if a person is suffering from, like, say, cancer, and that cancer involves, abnormal neutrophils, and you give drugs to get rid of those neutrophils, you may end up having neutropenia. Neutropenia means less number of neutrophils than normal. Right? So obviously, you may be susceptible to fungal infection. And the reason is neutrophils have reactive oxygen intermediate and other lysosomal enzymes, and they can easily get rid of these fungi by a mechanism of intracellular killing. The only difference is that there are some form of fungi which are there in the environment, like Cryptococcus. I'm going to talk about that, Cryptococcus neoformans. And in these fungal infections, they are pathogenic, or they have some of the factors that are going to stop your adaptive immune response. And the way they do it, that they inhibit the production of cytokines such as TNF and IL-12 and stimulate the production of IL-10. So if you remember, we talked about activation of macrophages. So if you don't have these cytokines, your macrophages will not be activated. So what do you mean by activation of macrophages? When I say that these fungi inhibit macrophage activation, what are the consequences of not having your macrophages activated? I normally don't take a lecture at 9, so it's like it takes a while before adrenaline kicks in or whatever, melatonin. It's a very simple, common question. I think these are some of the basic concepts that you have to have. You have any? Say again? They won't describe whatever they didn't know. Okay, activation of macrophage. What else? And the simple immunological terms, and we did go through that in detail. And there were quite a few questions as well. Macrophages mean that macrophages now start expressing all those receptors on the top that are required for phagocytosis, like Fc receptors. Activation of macrophages means that now they will be able to translocate and put out those MSC class 1 and 2 surface molecules, because they normally are not in that situation. So once they get activated, they're going to show off Fc receptors, they're going to show off MSC class 1, they're going to show off MSC class 2. They will begin to secrete cytokines, and as we said, they will begin to become activated, ready to go. So they will have all those things that are required for proper antigen presentations. Correct? So this is what we mean by activations. And remember, we talked about pro-inflammatory cytokines and anti-inflammatory cytokines. What are pro-inflammatory cytokines? Yes. Human necrosis factor, and there's a list of that. Say it again? I didn't get that. Interleukin 12, okay, IL-12, good. Gamma interferon. And there are anti-inflammatory cytokines like IL-10, IL-4, right? So these are some of the important things that you need to know in terms of immune system. And remember, these things are going to come again and again. They will come again and again. This is like the basic level of understanding that you need to have. And see, that makes me concerned, because your class, I didn't have a cumulative exam, hoping that everything's going to be retained as we go on to P2. The purpose of cumulative exam usually is that we want some pieces of information to be retained till the end. So maybe you're going to escape this time, and I may want to add cumulative exam for these basic concepts of immunology for the next class, because this is something that I really want you to know before you move on to your P2, because I'm pretty sure the very first day Dr. Elmer is going to come, is going to ask you the same question. We're going to talk about pro-inflammatory cytokines today and drugs. What are pro-inflammatory cytokines? What is activation of macrophages? Right, so this is something they really have to have a good grasp on. So this is something very important for you to know. Anyway, I don't want to go, it's just a repetitive slide. What is an adaptive immune response? What is CD4, CD8, Th1, Th2? All these things will come again in fungal infection, because fungal infections have a very tight link with immunity. Because as I said, people who have immunodeficiencies, they usually present, and you must have heard Candida. Candida is one of the commonest infections that people usually present if their cell-mediated immunity is compromised. Right? So you should expect some of the basic concepts of immunology in your mycology exam as well. Because unless and until you understand the adaptive immune response in terms of fungal infection, you will never be able. The second important thing you have to remember, what is the role of antibody-dependent cell-mediated cytotoxicity, especially related to fungal infections. And I think I've already posted it, but you can read it. I would advise you to go back and look at the immunology lecture as well. So you basically know what are Th1 responses, what is Th2 responses, antibody-dependent cellular cytotoxicity, and what are the receptors that are required. Because many a time when are we going to discuss about the target molecules for your DAS courses, we'll be talking about those specific molecules, their chemical structure, and how do we devise the drugs that are required. Okay, just a repetitive slide again. Fungi are eukaryotes. You talk about that. Characteristic, they are multinucleate or multicellular organisms, and they grow as hyphae, and they are present everywhere. And then even we have baking, brewing, and other pharmaceutical industry that take advantage of this fungi, and they are normally produced. I just got this particular slide from the journal Microbiology lecture, and I must repeat, I want you to go and read that as well, because you would not be able to understand anything in mycology if you don't know the basis of fungi. And then also reminds me that you have to really remember that many of the courses offered, even in biochemistry, microbiology, immunology, these are graduate level courses. So there is a certain level of efficiency and there is a certain level of competency that's expected of you. Right? And unfortunately, those of you who may have to remediate in the summer, so they shouldn't really expect that this is just going to be run through. It's going to be really competency based. So you really have to come up to that level of competency where you are given a B or C in a professional graduate course. So it's not like an undergraduate kind of a thing. So many things, I mean, I've just noticed, because if you're still struggling with some of the commonest concepts of immune system, you may have a difficult time in the final test. I can just warn you ahead of time. All right. We talked about mycology, mycosis. When we say pathogenesis, basically we're talking about tissue death. That's how the mechanism, the viruses causes tissue death. Their mode of causing tissue death is different than bacterial. Because, for example, if you have pus formation, the chances are that there are bacteria there. If you have smell, typical case, I would not teach you here, but I may teach you in the DAS courses, is a typical case of vaginitis. In vaginitis, normally when we talk of vaginitis, we have a bacterial vaginitis, you have fungal vaginitis, and all those vaginal discharges we usually talk about, and we talk about the color, we talk about the smell, we talk about many biochemical tests. But you should keep in mind, whenever these microorganisms cause pathogenesis, this means the damage to your tissue. So that actually will tell you the tale. Is it because of viruses, because of bacteria, or is it because of fungi? So fungi, again, you may have noticed on your own, if you have a very, very ugly or bad athlete's foot, you will see all those white plaques and all those tissue deaths. This is sometimes painful as well. Why is it that sometimes the fungal infections are painful and others are not? And this is a question of your physiology now. When you must have noticed, right? If you have athlete's foot, sometimes it's painful, sometimes it's not painful. What's the difference? Why is it so? Yes?
I'm not sure, but would it be painful if it's like a nerve involved?
Yeah, very good. Simple. When the nerves are involved, that's where the pain comes from. Remember, if you know the anatomy, and I'm going to talk about that in a little bit detail in the second lecture. If you really want to understand mycology, you really have to know anatomy of skin, physiology of the skin, and biochemistry of the skin. This is something that I really want to emphasize upon, and I'm going to take some time on that. Remember, when I said that in burns, for example, some of the superficial burns are painful. Some of the deeper burns are not painful, because if you remove all those neurogenic layers, there will be no pain. They are aesthetic. Right? So this means that now the tissue damage has gone to a deeper level where the nerves are there. Right? So it's stimulating and irritating those nerves. Right? You know what is root canal? What do they do in root canal? Huh? They do what? What is it? What is the basic concept of root canal? They take out the wisdom tooth? Molar tooth. Is something to do with molar tooth only? What is it? What happens in the root canal? Yes. Okay. So what? So if they kill the nerve, what is going to happen to the tooth?
No pain.
So this is the only thing that they do in the root canal? Okay. I'm going to give you this assignment. Just go and Google what exactly do they do. Each and every tooth has a blood supply, a nerve supply, right? And what is it exactly they're trying to save? Something is a protective procedure. They want to save your tooth. That's what they tell you. When you go to the dentist, they say, I'm going to save your tooth. So find out what does he mean by that. Understand? Maybe it'll give you some idea as to what are the basis of antifungal drugs, which we'll cover in a couple of days. So maybe day after tomorrow I'm going to ask you, why the dentist say that I'm going to save your tooth? Right? What is it? Is it only pain or something else as well? All right. Let's move on. As far as pathogens are concerned, there are 100,000 named species, and now I want you to remember each one of them. Will you be able to do that? No, I don't want you to do that. I don't even want you to remember 500 of those, which call human diseases, but obviously I just would want you to remember at least 10 of those. At least 10, or a little bit, one or two more. 10 of the most common fungal diseases and fungi of human concern. Most of them are molds, and some of them are pathogenic yeasts. What is dimorphic? That was something that we discussed in the first lecture, a process called dimorphism that wasn't present in bacteria and viruses, but it's very important in fungi. What is dimorphism? Okay.
So it exists in two different forms?
Why? Yeah, multicellular yeast and molds. So all those fungi that can exist in two forms. Which one produces by sexual pathway and which one produces by asexual pathway?
Multicellular sexual with yeast.
You sure? You sure, Evelyn? Are you just guessing? Here. Yeast is? Asexual. Okay. All right. Many a time the problem that we have is that a fungi may be developing in a host in one form, and we are unable to provide those necessary media for it to grow in the lab. That's another challenge that we normally have. But what we normally do is that there's another agar. I just want you to remember, for almost all the fungi, it's Seborrhoeids dextrose agar. So if you're asked what agar most of the fungi grow, the answer is Seborrhoeids dextrose agar. So moment you sent your specimen for growth, you're looking at fungi Seborrhoeids dextrose agar. Most of these pathogenic fungi are dimorphic. So they have this ability to exist in two different forms. So when there is a need for them to divide asexually, they're going to divide. When there's need for them to go for a sexual pathway, they're going to go and divide that up. And some of the fungi, especially when they cause infection, they basically are in the budding form. Single yeast, many of the fungi which cause infection, you can see from here, they are single cell yeast form. Because remember, if they are larger, it will be difficult for them to go into the tissues and proliferate. So it depends upon the microenvironment they are in. When they are going to cause disease, they will exist in a single form. Okay. Now, some fungi are systemic pathogens. These are the terms I'm going to use: opportunistic fungi, systemic fungi, primary pathogens. So these are some of the words I'm going to use. I just want you to pay attention. For example, the 2 out of those 10 or 12 fungi that I want you to remember: Histoplasma capsulatum and Coccidioides immitis. These are those infections. They are systemic pathogens. This means they're going to go into your blood and they may involve your whole system. And many a times this happens if you have compromised immune system. Histoplasma capsulatum and Coccidioides immitis will do that in detail in coming lectures. Then there are some of the opportunistic pathogens. I mean, this doesn't by all means is a complete list of that, but as I said, we'll just pick up some of the common fungi and discuss that. Candida remains on top. So Candida infection is one of the commonest opportunistic fungal infection. Candida and Aspergillus. Aspergillus is another one that's an opportunistic pathogen, and they would only cause a disease if your immune system is compromised. Otherwise, you should be able to fight back and resist Candida infection. Many times, if you give a broad spectrum antibiotics, they usually have a secondary Candida infections as well, and steroid use. So all those things you really have to keep in mind. Now, another important determinant of pathogenesis of fungal, because that's like the title of today's lecture is that I'm going to talk about the pathogenesis of fungal infection. The pathogenesis of fungal infection depends upon many factors. Many factors. Number one, for example, the form of mycosis. Is it yeast form or mould form? What is the form of mycosis? And then severity of infection. Inoculum size. Are you being bombarded with like a couple of those organisms, or this is like a full-blown aerosol or inhalation that you really get? So the inoculum size is also important. And then again, the site and method of entry into the body. So site and oral, skin, mucous membrane, as I just said, that if you've been operated and they open up abdomen or any part of your body, and then these fungi happen to go in, then again, you are giving them an opportunity to basically go in a place that they would have never expected to go. So that again would determine as to what kind of pathogenesis are you expecting. This also will mean that you have to be very, very careful when are you scrubbing or using aseptic techniques in doing all those invasive procedures, because you are going to introduce bacteria, viruses, and fungi into your system. And then again, will also piercing, tattooing, all those things also will be a part of that. Okay. Relatively few are sufficiently virulent. Some of them are sufficiently virulent that even if you have a normal immune system, they can cause disease. We call primary pathogens. So by definition, they are capable of initiating infection in a normal, apparently immunocompetent host. So some of these fungi are really virulent. So they have developed those pathogenic markers that they're going to go into your system and cause disease. What they normally do is that they're going to come and colonize you and then find a suitable microenvironment and look for the nutrition substrate, and then they are going to go and fight your immune system by kind of, immunoevasive mechanisms or finding some other kind of avoidance of immune responses. So they also have developed those kind of mechanisms that they can fool your immune system and not get recognized, so you would be unable to mount an immune response. So these type of fungi are primary pathogens. Right? Okay. Primary fungal pathogens, I'm going to just talk about 4. So these are virulent fungi that will cause disease even if you have normal immune system. Blastomyces, dermatitis, and again, if you pay attention to the words, if say dermatitis or titis, this means it's going to go and invade your skin. Derma is something to do with the skin. Right? Coccidioides immitis, Histoplasma capsulatum, and Paracoccidioides brasiliensis. So these are some of the important primary pathogens that will always cause disease if you happen to come in contact with that. And always keep in mind, many times, those people who are working in labs, those people who are working in those environments in pharmaceutical industries where they have a culture of these fungi and you're developing drugs against them, you're doing all those killing assays, so these lab people may be exposed to that. Or if you happen to go in those areas where there's a high incidence of these 4 primary fungal pathogens, they will definitely cause disease in a normal host. Right? So Candida is not one of them. Candida is an opportunistic. Aspergillus is an opportunistic. Okay, now as far as the general characteristics of these primary systemic pathogens are concerned, mostly they are respiratory infections. So they're going to go and you will inhale them. So they are respiratory infections, and none are obligate parasites. I won't go in detail what are obligate parasites. I think you are already familiar with that. The most important thing you have to keep in mind is that these 4 primary